Alright, in this video here we're going to talk about the definition of a one-to-one function. And a one-to-one function is a certain type of function, or it's a certain quality that some functions have. And the reason we care about a one-to-one function is because when we start talking about inverse functions, a function only has an inverse if the function is a one-to-one function, right? So if the function is not one-to-one, then you can't have an inverse of it unless you restrict the domain of it to make it have an inverse. But we'll get to that when we talk about inverse functions, which will be one of the videos that I do soon. But here, for a one-to-one function, so the definition of a one-to-one function: a function is one-to-one if no two elements, or x's, have the same image or y value. Right? So no two x values. So if I have two different x values, they can't both have the same y value. Right? If two different x's have the same y value, then the function is not one-to-one. Right? So another way of saying that in mathematical terms, f of x1 is not equal to f of x2 whenever x1 is not equal to x2. Right? If I have two different x values here, they cannot have the same y value, right? The same output value. Right? So two different inputs have to have two different outputs. Right? If two different inputs ever have the same output, then the function is not one-to-one. Alright, so just to compare to the definition of what a function is, and if you didn't watch the video I did on the definition of a function, you might want to check that out. But the definition of what a function is that for each x value, for each input value, you only have one y value. You only get one output, right? So if you put a number into the function, only one single number comes out. For each x, there's only one y. That's what makes something a function. Right, the one-to-one function is going the other way with it. For each y value, for each output value, it only comes from one single x value, one single input. Right, that's what makes something a one-to-one function. Right, so that's why they call it one-to-one. For one x, there's one y. For one y, there's one x. Right, if anything gets repeated, if one x has two y's, it's not a function. If one y has two x's, it's not a one-to-one function. Right, so one-to-one, one x for every y for every x. Right, that's what we mean by the definition of a one-to-one function. So you think about it in those terms, 1x for 1y for 1x, it makes sense that that's why they call it a one-to-one function, and that's what the definition of it is. Alright, so that's the definition of a one-to-one function. I'm going to pause the recording and erase the definition here, and then put up a graphical test we can use to test whether or not something is a one-to-one function. Alright, so if we're going to test whether a function is one-to-one, one of the things we can use is what we call the horizontal line test. Now you may remember, and if you haven't watched the video on this, you can go back and look at the video I did, but when we talked about the definition of a function, which is for each x value, there's only one single y value, for that we use what we call the vertical line test. Right? If you draw a vertical line anywhere on the graph of the function, if that vertical line only touches the graph one single time, that means it is a function, right? Because that vertical line represents one single x value. And for that one single x value, if it only touches the graph one time, that means that x value only has one y associated with it, and for one x there's one y, therefore it's a function. Well, for a one-to-one function, we use the horizontal line test, a line going across, right? So the horizontal line test says that a function is one-to-one if and only if no horizontal line intersects its graph more than once. Right? So a horizontal line represents one single y value. Right? Remember, the definition of one-to-one that we just talked about, if the function is one-to-one, that means each y value only comes from one single x value. So if you draw a horizontal line, that represents one y value. If that line only hits the graph once, then that means that one y value only comes from a single x value. Right? Whereas if that horizontal line hits the graph two different times, or more than two times, then that one y value has two or more different x values, and therefore it's not one-to-one. Alright, and we're going to do a couple examples here using the horizontal line test. So if all that stupid stuff I was just doing with my hands didn't make any sense, when we actually draw some pictures, hopefully it will. Alright, so is f of x equals x to the third power one-to-one? Alright, so the graph of f of x equals x to the third, and if you looked at the videos that I did on parent functions and transformations of graphs, you should have an idea of what the graph of f of x equals x cubed looks like. Alright, the cubic function, the graph looks like that. Alright, so that's the graph of y equals x to the third power. Alright, and then we want to see, is that function one-to-one? Alright, remember, one-to-one means for each x there's only one y, for each y there's only one x. Right, so we know it's a function because if I do the vertical line test and I draw a vertical line anywhere on the graph, it only touches the graph one time. To test if it's one-to-one, I use the horizontal line test. So I'll just draw a couple dotted horizontal lines here, and we can see that no matter where I draw that horizontal line, it's only going to touch the graph one single time. Right, so f of x equals x to the third, yes, that is a one-to-one function because it passes the horizontal line test, right? Which, again, this horizontal line here represents one single y value, right? So let's say that this is y equals 8, just to pick a number, right? Well, that only intersects the graph here. That means y equals 8 only comes from one single x value, which in this case would be x equals 2. Right, 2 to the third power gives me 8. There's no other number that I could plug in here for x and raise it to the third power that would give me that same output of 8. Right, and same for any other horizontal line that I draw at any other y value. You know, for y equals 0, well, the only number I can plug into this that's going to give me 0 is 0. Right, 0 to the third power is 0. That's the only number that raised to the third power gives me 0. Right, so that's what we mean by a one-to-one function. The horizontal line test, again, if it touches that graph more than once, it's not one-to-one. It can still be a function, it's just not a one-to-one function. All right, so x cubed is one-to-one. Example B here is f of x equals x squared one-to-one. Right, and once again, you should know what the graph of x squared looks like. Right, that's one of the parent functions that you ought to be aware of. X squared is the parabola that looks like that. All right, and you can kind of tell just by looking at it that it's not going to be one-to-one. Right, so if I use the horizontal line test here, I only have to draw a horizontal line anywhere up above the vertex of the parabola there, and I see that that horizontal line touches that graph twice. Therefore, y equals x squared is not a one-to-one function. All right, because for that one single y value, and just to put some numbers on it, let's say that this is y equals 4. Again, just to pick a convenient number here. Well, y equals 4 for this function can come from two different x values. Right, y equals 4 when x is equal to 2, right, because 2 squared gives me 4. But also when x equals negative 2, right, negative 2 squared also equals positive 4. Right, so that one y value comes from actually two different x values. Therefore, this function is not one-to-one. Right, remember, one-to-one. 1x gives you 1y. 1y only comes from 1x. All right, so it is a function. It's just not a one-to-one function. Right, it passes the vertical line test. Right, each x value only gives you one single y value. But each y value does not just come from one single x. All right, so that is the definition of a one-to-one function. That is the horizontal line test that we can use very easily. If we know what the graph of the function looks like, it's very easy to test and see whether or not it's one-to-one, just drawing that horizontal line. If it touches the graph only one time, no matter where you draw the horizontal line, if it only ever touches once, it's one-to-one. If any horizontal line hits that graph more than one time, it's not a one-to-one function.